Do you find the concept of the end of the universe fascinating? We don't know if it's possible to travel to other universes, but we do know that some galaxies that were once part of our universe are now traveling to other universes. The diameter of the observable universe is the same no matter how we look at it, because the fact that the universe is 13 billion years old gives us the maximum diameter of the universe. So when we look at a galaxy 47 billion light-years away from us, we are actually looking back at the universe in which we live. But what else is out there? The question of what is beyond space is a difficult one, as it involves exploring the boundaries of the universe. Scientists have come up with a variety of theories based on observations of the universe, and these opinions are based on logical conclusions drawn from those observations and imagination. One difficult question when thinking about the edge of the universe is what is on the other side. If the universe has no end, then it can be infinite in size. Few scientists adapt to an infinite universe, as all kinds of disturbances could exist there. The truth probably lies somewhere in between, as scientists do not fully understand it. The word observable in this context means that something is within the physical limit of the speed of light. No signal could travel faster than light, so nothing beyond the particle horizon can be detected. However, is there anything beyond the universe? To answer the question of what is beyond, we must first define what we mean by universe. If you mean literally all things that can exist in space and time, then there can be nothing outside the universe. If you imagine the universe to be a finite size and imagine something outside of that volume, everything outside must also be contained within the universe. The universe, however, is a formless, shapeless, nameless void with absolutely nothing in it. It is still a thing and counts on the list of all things, so by definition, it is part of the universe. It has been nearly a century since academics first theorized that the universe is expanding and that galaxies farther away from us are receding faster. This is not because galaxies are physically moving away from us, but because the universe is full of gravitationally bound objects and the fabric of space in which these objects are located is expanding. However, this picture has changed in the last 20 years, since we first understood that this expansion is accelerating and that some galaxies will move away from us at an ever-increasing rate over time. Eventually, they will most likely be unreachable, even if we could travel towards them at the speed of light. Thus, the universe is disappearing as we age, and there is nothing humanity can do about it. The cosmos has been growing at an ever-increasing rate since its creation, according to cosmologists. They estimate that the oldest photons we can observe have traveled a distance of 45 to 47 billion light-years since the Big Bang. This means that our observable universe is about 93 billion light-years wide, plus or minus a few light-years. These 93 billion or so light-years contain all the quarks, quasars, stars, planets, nebulae, black holes, and anything else we could possibly observe. However, the observable universe contains only the light that has had time to reach us. The universe is disappearing. In order to understand the universe, we must first know its size. Our universe is estimated to be 13.772 billion years old and 28.5 gigaparsecs wide. However, this is just the beginning. Beyond space and time, there is much more to discover. It wasn't long ago that we thought space and time were the absolute and unchanging framework of the universe. However, Albert Einstein showed that different observers can disagree about the length of objects and the timing of events. His theory of relativity united space and time into one space-time. This means that space and time are no longer independent of each other. The mathematician Hermann Minkowski explained that only a unification of the two will preserve an independent reality. However, Lee Smolin of the Perimeter Institute of Theoretical Physics in Waterloo, Ontario, Canada believes that there is more to be discovered. He and a trio of colleagues want to take relativity to a whole new level by forgetting the home that Einstein invented for us. They say that we live inside a place called phase space. By understanding the distance between our eyes and the apparent displacement of our hand, we can calculate the distance to objects. This same approach can be used by astronomers to calculate the distance to stars and other celestial objects. Finally, by understanding how the universe arose from nothing, we can begin to understand its true size and scope. Our universe holds an incredible number of surprises, most of them we cannot yet explain with the technology available to us today. There are far too many questions to which mankind still has no answer. One of them is probably whether we are alone in the universe. Since the first edge of the Big Bang defines the boundaries of the universe, the most distant objects humans can see are also the oldest. So it's reasonable to assume they should be about 13.8 billion miles away. But the rapidly expanding early universe was an impenetrable plasma, and the universe is expanding faster and faster, so light from distant objects takes longer to reach us than previously thought. Based on such considerations, astrophysicist Richard Gott led a team that estimated the radius of the universe to be 45.7 billion light-years. The Big Bang theory states that the universe arose more than 13 billion years ago from a single, unimaginably hot and dense point known as a singularity. It did not occur in a pre-existing space, but rather initiated the expansion and cooling of space itself. It explains many of the things astronomers see through ground and space-based telescopes and is responsible for a faint glow that can be seen throughout the universe. This glow is the leftover heat from the birth of the universe, which has now cooled to just a few degrees above absolute zero. In short, it is a remarkably strong and elegant explanation of how the observable universe came into being. In addition, the chance is also high that our current technology simply cannot be perceived by others. The other possibility would be that we are too late and all other intelligent life forms are already extinct. It would not be unlikely considering the age and evolution of the universe. There is more on this later in the video. At the point about the big filter, it might discourage you a bit to think longer about this paradox. After all, one of the greatest mysteries of our history is to find out if we are really completely alone in the universe. It would be a great achievement to establish peaceful contact with other planets and other life forms. Home and alien probes. We have been trying to make contact with other life forms beyond Earth for several decades. In doing so, we try to consider everything that could lead to possible communication problems. Two of the first attempts were the Voyager 1 and 2 probes, which we sent into the unknown in 1977. Both probes are currently in interstellar space and are still sending data back to Earth on a regular basis. For us, this is of course excellent, even if the developers at the time would not have expected that both would still be functioning after 45 years. On board both are golden records. This tells a possible other civilization where the probes come from and how they can locate us. In addition, the record itself contains some recordings of the sounds of Earth. This includes music, nature, and voices of humans. But whether this will be understood by another life form remains to be seen. Another already debated possibility for the future would also be to send robotic probes. One of them is the so-called von Neumann probe, which replicates itself again and again, and thus can send many offshoots in different directions. So far, however, we have not undertaken this. The question here is whether extraterrestrials have also sent such probes or robots. Up to now, we have received no message, which we cannot explain ourselves or by space phenomena with the size and age of the universe. It's difficult to estimate how long such a message would take to reach us. Or to return to the Fermi paradox, there is simply no one out there who could make contact with the great filter. When we speak of the Fermi paradox, the word filter comes up again and again. That we cannot prove these either, but they give us the possibility to explain why we could possibly not discover any life yet. Have we as humans already broken through some of these filters? Or do we still have these ahead of us? And what about other civilizations? These questions are only theoretical and difficult to answer. Perhaps we humans are so unique as a complex life form that not many others can break through this filter, and we may be the first. The emergence of complex life may be so unusual that we are truly unique. Even our human evolution has taken many thousands and thousands of years to get here. It could be that this stage of intelligence and life is rarely if ever reached on other planets. For us, this variant would be good because with our emergence, we have already overcome the big filter and can penetrate undisturbed into space. It might be, however, that the filters still lie before us. Even currently, we are struggling with natural and self-made problems like climate change, nuclear weapons, or natural disasters. Possibly, these are all things that every civilization faces and cannot overcome. Becoming a Type 2 or Type 3 civilization is likely to involve many obstacles that cannot easily overcome. Currently, we can only speculate what this possible filter might be that lies ahead, and possibly many other civilizations before us have already failed at it. Which is why we have no clues. This idea would be quite depressing because we don't know what lies ahead. Planetary quarantine and boundaries. Another issue that comes up in this context is planetary quarantine and boundaries, that we live here on our Earth and have not yet managed to colonize other planets or moons. Therefore, it's extremely important to protect our own planet. We don't know what could possibly harm us. In addition, we are not treating the Earth very well either. Climate change is probably one of the biggest problems of mankind and will not be solved anytime soon. Current pandemics and diseases also show us how quickly civilization can be paralyzed. It is important to protect the Earth from possible external impacts. People from the Moon or the ISS are quarantined, so that they do not bring unwanted material from space back to Earth. We cannot predict what the consequences might be if material unknown to us were to fall among normal humanity. Life was created. But how likely is it that even some form of life exists outside of our Earth? That is difficult to say. There is always news about possible discoveries of extraterrestrial life, however small and insignificant it may be. Currently, it is even believed that life originated from outer space itself. Our bodies are theoretically nothing else than material from the universe. It is possible that an asteroid or comet landed on Earth millions of years ago and brought back individual living cells. With our current state of knowledge, we can only speculate whether there is more out there in the universe than just us. Maybe we are just too unique and really all alone. In space, we would explode. Since 1961, when Russian Yuri Gagarin became the first man in space, hundreds of space travelers and astronauts have ventured into the unknown reaches of space. Until now, we have not been able to travel very far from our usual earthly environment because we humans need the Earth's gravitational pull and oxygen to survive. Outside of space shuttles and space stations, a deadly void begins for humans. There has been much speculation about what happens when a human goes into space. Adventurous assumptions, calculations, and false beliefs circulate. One of these false assumptions is that humans would explode in interstellar space. This fairy tale came about because people assumed that the pressure in empty space would be so great that people would first be compressed and then cooked internally. Finally, according to this assumption, a body would simply explode in space, but this is not true. Space is often portrayed as a cold, inhospitable, even deadly place, where the constant vacuum causes the blood to boil and a body to burst. But the fact is that there is practically no temperature in empty space because nothing can conduct either heat or cold. If a human were to enter space, he probably would not feel much difference in temperature. Tests showed that the cosmic background radiation must theoretically be -391 degrees Fahrenheit cold. Nevertheless, this temperature cannot be conducted because of the lack of matter in space. Much more hostile to an organism than temperature would be the constant vacuum of space. A body would very well experience sudden decompression, which would very likely lead to the immediate rupture of the lungs and therefore death. There is no gravity in space. Space is empty and humans experience themselves as weightless. Consequently, there is no gravity there, but this is not true. In the whole solar system, there is gravity. Only it is more or less strongly pronounced at different points. Gravity is a physical phenomenon which describes the forces of attraction of the celestial bodies. All bodies that have a mass attract each other in the direct environment of planets, or also the Sun. This attraction is particularly strong, but it also exists in space between the planets and the Sun. Because otherwise, neither the planets would keep their distances to each other nor would they circle around the Sun in orderly orbits. However, the magnetic conditions in space change, they decrease. We small bodies experience weightlessness in this low gravity. Larger bodies like planets on the other hand are held in place optimally by this weak gravity. Black holes suck up matter. It is a widespread assumption that black holes, the giants of space, would simply suck up and eat entire suns and planets. Black holes are considered the voracious, all-destroying entities in space. In fact, it has already been observed that stars that have come close to a black hole are literally slurped in. Black holes in their entirety, however, are so far only an astronomical assumption. No one has ever seen one up close. Strictly speaking, one does not see them at all. They consist of dark matter, and this is, strictly speaking, not dark or black. It simply just does not exist. Black holes are fields of nothingness, in whose proximity an unbelievably high gravitational force acts which pulls matter apart. What happens inside the holes and whether there is an inside at all is unknown. Scientists have now discovered that dark matter does not physically have the ability to suck anything into itself at all. What it really is and what goes on at or in black holes is still a mystery. That we were never on the moon. In 1969, Neil Armstrong and Buzz Aldrin were the first humans to put their feet on the moon. Some 50 years later, conspiracy theorists claim that it was all a fake. The moon landing of the Apollo 11, and also further NASA moon missions, had originated in a film studio on Earth. They claimed, as proof served irregularities with the gravity, the fact that the feet of the astronauts did not whirl up dust on the moon's surface, alleged statements of co-workers of the film studios, and a suspiciously blowing US flag. Since the moon has virtually no atmosphere, there was no wind there either. Millions of people believed that the moon landing was fake at the height of the conspiracy period. In the meantime, most of the claims have been credibly disproved. The flag flew because it had been moved by setting into the lunar soil. On some photographs, it can even be seen how Buzz Aldrin tries to steady the flag, laboriously, with the thick gloves of the bulky spacesuits. Despite this evidence to the contrary, polls showed that about 1 million Americans still firmly believe the landing was faked. A day has 24 hours and a year has 365 days. You probably thought so until now, but that's not the case. Strictly speaking, it is so that neither the day nor the solar year can be divided exactly in time measurements. The circulation speeds of the celestial bodies are not as completely linear as we Earthlings would like to have it. The Earth turns once around itself in 23 hours, 56 minutes and 4 seconds. Thus, each day, about 4 minutes are missing, and or we have on our clocks a time window of 4 minutes plus per day, and this is similar with the year. Our Earth turns once around the Sun within 365 days, 5 hours, 48 minutes, and 46 seconds. But we have a year with 365 days. Other than the 4 minutes daily, this inaccuracy can't be swept off the table so easily, which is why our time makers came up with the leap year. Every 4 years we get 1 day more at the end of February to stay up to date. According to recent measurements, the Earth sometimes even moves around Sun in 366 and a quarter days. How this inaccuracy might be adjusted or it's approved permanent is not yet known. The Great Wall of China can be seen from space. It is one of the few wonders of the world that has survived into modern times, begun in the 7th century BC as a protection against nomadic equestrian peoples. From the north, the wall is one of China's landmarks. People are proud of the structure, and around the world, it is said to be the only man-made structure that can be seen from space. Sometimes it is even said that the wall can be seen from the moon, but the moon is so far away from the Earth that no detail can be seen on the Earth's surface. It is different, however, with the ISS space station. Astronaut Alexander Gerst explained in 2018 that you can't see the Great Wall of China with the naked eye, but with a good Photoshop, you can. Humans are descended from apes. About 6 million to 9 million years ago, humans are thought to have slowly risen from the trees. From ape-like creatures they evolved into increasingly upright walking humanoids, and finally modern humans. Genetic tests actually showed a 98% match to chimpanzees and bonobos still living today. Nevertheless, there is still no evidence that modern humans are really descended from apes. After all, our genome also shows a 95% similarity to that of domestic pigs. Nobody would therefore think of claiming that we are descended from pigs. So far, dozens of pre-human species have been found worldwide. Many of them were reasonably upright walking, hairy, and ape-like beings. However, in the evolutionary chain, transitional stages from the all but still quite primitive prehistoric people to modern humans are missing. A riddle which science still cannot explain. Conspiracy theorists maintain therefore that modern humans could have developed by extraterrestrial influences. The solar system consists of 9 planets. Since the discovery of Pluto in the year 1930, We had 9 planets in the solar system. Until today, this number holds itself in the heads of humans, but this is not so anymore. For one thing, Pluto is no longer a true planet since 2006, but rather a dwarf planet. This classification also reveals another planetary fact of our solar system. There are hundreds of planet-like structures in our solar system. Most of them were found in modern space research at the outermost edge of the solar system. In the so-called Kuiper belt, dozens to hundreds of spherical formations orbiting the Sun suddenly made the definition of a planet unclear. Researchers therefore decided to attach official planet status to certain conditions that Pluto could not meet. It now has its own category alongside other dwarf planets such as Makemake, Pomez, and Ceres. Hundreds of other mini-planets are currently unexplored or unlapped. Newton dropped an apple. The great mathematician and astronomer Isaac Newton is a legend when an apple fell on his head or when he himself accidentally dropped an apple. He is said to have had the idea for the theory of gravitation. This story is still familiar to every child from physics lessons, but it is not quite true. There is very little evidence for the story. In the archives of the London Royal Society lies a manuscript of a man named William Stukeley, the author of the Newton biography, Memoirs of Sir Isaac Newton's Life. In it, Stukeley wrote, "After dinner, we went into the garden in warm weather and drank tea in the shade of some apple trees. He told me he was just in the same situation when the concept of gravitation had earlier occurred to him. It was caused by the fall of an apple, when he was sitting there in a thoughtful mood. Why should this apple always fall vertically on the ground, he thought to himself. However, it is known from other sources that Stukeley was urged to present an embellished picture of Newton, who was otherwise very unpopular because he was known to be egotistical and opinionated. Whether the story is really true, or whether it is biographical propaganda, is unclear to this day. Gravity is a force. The law of gravity of Isaac Newton is that the attraction of two bodies due to gravity is proportional to the product of the two masses and indirectly proportional to the square of their distance. From physics lessons, we have this somehow still in our heads, but not quite fully understood. Turns out, it does not matter because it's the same for the great minds of science. Nobody has really understood gravitation until today. One can only experience and perceive it. Thus, gravity is actually also no force. Behind gravity, which keeps bodies in space and place, and allows them to move on certain paths, there seems to be something like a cosmic principle of order, which forces make it possible, is unknown to this day, and there they were. 10 popular but wrong assumptions and misbeliefs. We hope you like this small lesson on the topic of the cosmos, its objects and forces, and Jupiter and its moons have always fascinated mankind. Now, the Juno spacecraft is providing spectacular images and new insights into what it looks like inside the gas giant, as well as more details about the moons that could harbor extraterrestrial life. Finally, we know what the inside of Jupiter looks like. One of the biggest research breakthroughs of the Juno probe is the discovery of the planet's structure. This begins with the core. A majority of scientists are certain that this is made of ice dust and heavy metals, and formed at the beginning of the solar system. Some scientists assume that there is no solid core, but it's only a concentration of helium and hydrogen. The temperature near the center is about 43,000 degrees Fahrenheit. The gas giant rotates as a rigid body and has an atmosphere with a depth of almost 2,000 miles measured from the top of the cloud cover. For comparison, the Earth's troposphere has a height of 9 miles. Like every gas planet in our solar system, Jupiter has its own ring system. Researchers were surprised when they analyzed the data. They discovered an asymmetrical arrangement of north and south poles. This is an unexpected discovery. Both poles have a zone that emits radiation. The radiation source at the south pole is much smaller. The phenomenon was discovered in 2000, but so far no explanation has been found. Jupiter's magnetic field actually has two south poles, one near the geographic south pole and one near the equator. The behavior of the gravitational field is striking in the observations. The gravitational field is the zone that attracts another body. Current realizations conclude Jupiter is not spherical, as the planet form would suggest, but pear-shaped. Whether this is a constant trait or equalizes out at times remains unclear. The planet owes its color patterning to the storms that race across its surface as the giant spins on its axis in just 10 hours. Well known is the red spot. This cyclone, twice the size of the Earth, reaches up to 300 miles deep. It is sandwiched between two jet streams, also called jet stream winds. It has been circling the surface for 200 years, but is gradually shrinking. In addition to this well-known storm, Juno has provided the first glimpses of Jupiter's poles, which are also dominated by cyclones. For a long time, the South Pole showed a pentagon of one large central cyclone and 5 smaller storms. In November 2019, a sixth vortex was added, and since then a hexagon exists there. The North Pole is a hexagon, that is 8 cyclones orbiting another cyclone. The small storms are almost all at least as wide as the US. Both poles are colored dark blue. Jupiter's moons. Moons differ not in size from planets, but in that they orbit planets instead of the Sun. Jupiter has a total of 80 known moons, not counting the smallest ones. This system of natural satellites is called the Jovian system. The 4 most massive moons are Io, Ganymede, Europe, and Callisto. These 4 moons were discovered in 1610 by Galileo and Simon Marius. This was also the first time that astronomers observed celestial bodies orbiting a moon other than Earth. This discovery provided for heliocentric world models that do not put the Earth in the center. What would happen if humans landed on Jupiter? Jupiter consists mainly of helium, hydrogen, and a pressure that is difficult to imagine. As a result, temperatures prevail that are higher than those on the surface of the Sun. These circumstances make a landing on Jupiter impossible for probes as well as for manned spacecrafts. In addition, there is no solid surface on which a landing would be possible. The Galileo probe penetrated about 70 miles into the atmosphere before the wind, which reaches almost 300 miles per hour, and the 100-fold pressure of the Earth destroyed the probe after 58 minutes. A human being would not survive that, but what exactly would happen if this fact were ignored? The journey begins with a speed of 110,000 miles per hour. Because of the gigantic attraction, the dense atmosphere slows you down a lot. After about 3 minutes, the atmospheric winds hit you. The pressure is 100 times higher than on the surface of the Earth. Moreover, no light penetrates through the dense cloud cover. 430 miles below, the pressure is 1,150 times that on Earth. In a spaceship designed like a submarine, you could withstand the pressure down to here at a depth of 2,400 miles. The temperature is 6,100 degrees Fahrenheit. Your fall already takes 12 hours. At a depth of almost 13,000 miles, the pressure is 2 million times that of the Earth's surface. Here, the temperature is higher than that of the surface of the Sun. Chemical processes turn hydrogen into metallic hydrogen, which absorbs all light. The high density creates buoyancy, while at the same time, gravity pulls on you. Until the forces are equalized, you will be pulled to the center of Jupiter and drift away again. Then, you will remain motionless. Temperature of Jupiter. The surface temperature of Jupiter is a constant -229 degrees Fahrenheit at the surface. In fact, the planet can be hotter than the surface of the Sun. The reason for the low surface temperature is the heat source. This is the interior of the gas giant. Jupiter is too far from the Sun to provide significant heat. This moon is the 5th moon of Jupiter, and with a diameter of 2,152 miles, the 4th largest moon in our solar system. Io was named after a nymph, loved by the Greek god Zeus. He transformed her into a white cow to hide her from Hera. The name was suggested by Simon Marius, but was not so named until the middle of the 19th century. Until then, moons were numbered consecutively, and Io was Jupiter's moon number 1. NASA describes the moon's appearance as a pizza with lots of cheese and some tomatoes and olives. Radiation on Io is 1,000 times the lethal dose for a human. Io hosts 400 active volcanoes and mountains larger than Mount Everest. Europa. This is the smallest of the 4 Galilean moons. Its diameter is 1,939 miles, which is smaller than the Earth's moon. Galileo recorded Europe as Jupiter's moon number 2. The moon was named after another mistress of Zeus. So that his wife, Hera, would not find out about the mistress. He sought out Europe in the form of a bull. Europe is an icy moon. Its surface temperature is -364 degrees Fahrenheit at the poles and -184 degrees Fahrenheit at the equator. The ice surface varies in thickness from 50 to 106 miles. The ice provides a strong reflection of light, the strongest in the solar system. Researchers suspect that there is an ocean beneath the thick layer of ice. In 2012, using the Hubble telescope, scientists discovered a possible plume of water spraying into the ocean from the South Pole. In 2014 and 2016, other such sightings were reported. The surface of the Moon has many cracks. The theory is that Jupiter's gravitational pull creates tides in the ocean. The ebb and flow of the tide stresses the ice layer, which cracks. In addition, Europe is believed to have played tectonics. Europe has considered a potential life source because of its water and oxygen. Whether living organisms are present on a microscopic level is to be investigated in 2029. Ganymede. It is the largest and most massive moon in the solar system, and with a diameter of 3,273 miles, the ninth largest object in the solar system. If Jupiter did not outshine it, it would be visible to the naked eye. Jupiter's moon number 3 was named after the cup-bearer of Zeus and his lovers. Thus, it is the only one of the Galilean moons with a male name. The moon has dark areas with many impact craters. In addition, there are lighter, younger areas with fewer craters, but more trenches. Ganymede has 2 continental plates, but tectonics came to a standstill. Large parts of the moon are covered by ice. A saltwater ocean is suspected beneath the surface. The probability for extraterrestrial life is lower on Ganymede than on Europe. The reason is that the ocean could be frozen inside, and this moon does have a thin atmosphere of oxygen. Callisto, with a diameter of 2,996 miles, it's the second largest moon of Jupiter and was first named Jupiter's moon number 4. Ganymede is a nymph who was seduced by Zeus and became pregnant out of jealousy. Hera turned her into a bear. Callisto has the most impact craters of Jupiter's moons, an ice crust about 120 miles thick covers the moon's surface. The surface temperature averages -218.6 degrees Fahrenheit. It's considered the oldest of the moons. Its formation was simple. There is no tectonics, which is why the surface is flat and has remained largely untouched. A saltwater ocean is believed to exist beneath the ice. The moon is surrounded by a thin atmosphere of carbon dioxide. The Juno probe. On August 5, 2011, the Juno probe launched, built by Lockheed Martin. It reached Jupiter nearly 5 years later. On July 5, 2016, in 2017, the probe was supposed to crash on Jupiter, but now it's supposed to orbit it until 2025. The project cost $1 billion and was commissioned by NASA. Juno is the second probe to orbit the largest planet in our solar system instead of just flying by. It was named after the Roman goddess who was able to see through the clouds. The Greek variant of Juno is Hera. The first Jupiter probe was Galileo, which was in operation from 1995 to 2003. What are your thoughts? Which of these findings do you find most impressive? What is the most fascinating moon? Should more probes be sent to explore it? What is your take on this subject? Do you have any comments you would like to share? We eagerly await your response. Hit the subscribe button and never forget to share this video with others.